welcome to you from my living room. Here we are in testing and significance testing. And based on some information that we're going to gather, and I'm going to walk through this here with you a little bit. But we're going to start up here in the upper right-hand corner. And as we look at in the past year, this is a scenario, we had medical attention. So in life-threatening circumstances, when someone calls 911, they really need people to arrive within, here's my star up here, within 8 minutes. If they do not arrive within 8 minutes, then it gets much, much worse, obviously. All right, so that's always the goal, is to arrive within 8 minutes of the call that comes in. And in a particular city, last year, they had an average of 6.7 minutes. And in fact, 78% of them were less than 8 minutes, which you might think, wow, that's really good. But then you got to figure, well, 22% took over 8 minutes. And that's not great. I mean, that's almost a quarter of the time. You had some people waiting and it being more than 8 minutes when it was a life-threatening circumstance. And you're told as a department to make it better, improve. So they did certain things to make some improvements, and this what gets us to over here on the right-hand side. All right, we have so in the following year, they took a look after the following year of 50 of those cases. So they randomly selected 50 cases, and although not stated there, let's go ahead and put that in there. A random sample of 50 cases from this year had an average time of 5.9 minutes and a standard deviation of 3.1. Is this, or is that, significant evidence to show an improvement at a 5% level of significance? So first off, I noticed that, yeah, indeed, this is going to be a hypothesis test or a test for significance. I'm going to do a hypothesis test, HY, hypothesis test for the mean, because I'm talking about the average, is the average time. So when I'm doing that, my first step is always my null and my alternative hypotheses. My null hypothesis is mu equal to, and my alternative will be mu something. All right, so mu equals to, and I'm going to go with always, what's the status quo? 6.7 minutes. My mu here, what am I trying to prove? That there's an improvement. I want to say, did they improve? That is it now less than 6.7 minutes? Are they getting better at what they're doing? All right. It's not always going to tell you greater than or less than. In this case, it said improve, and you have to decide, what does improve, what does it mean? All right. And then I do my conditions. SRS is stated. 50 times 10 equals 500. Safe to say, safe to assume, over 500 critical cases last year. Therefore, independent. And you'll notice that I am writing all of it down. You're getting in the bad habit, some people are getting in the bad habit of not indicating what all of these things actually are. They write SRS and then that's it. In this case, simple random sample is stated as part of the problem. So you need to say it is stated. If you need to draw a line back up to the original part of the problem, then I'm going to go like this. Stated. It said it was an SRS in the sample. All right, I cannot say for the second step 5 times 10 equals 500, therefore, independent, or I can't say, capital N, if I just say N greater than 10N, and I don't do anything, I don't show any numbers, and I just say therefore independent, no, you're not going to get credit. All right, and all of these conditions count as one thing. So you miss one of them, and you get no points for all of them. So don't think that it's all these multiple steps. You got to list all of them out and do them all correctly if you want to get full credit. Miss one of them and it goes from an E to a P. You miss 2 of them, it goes down to an I. So those, of the 4 conditions, you might get 2 of them right, but you get 0 points for it. All right, and then N equals 50, which is greater than 30. Therefore, sampling distribution is normal. Therefore, the sampling distribution is normal. Do not say, therefore, it is normal, therefore the distribution is normal. All of those, you will lose all credit. In all of these conditions, you will then get 0 points. All right, you say anything, this is such a big deal, the central limit theorem, that if you say, therefore, the distribution is normal, you're going to get nothing. You have to say sampling distribution is normal. All right, sigma is unknown. I'm going to use t. All right, even though up here it says standard deviation, that standard deviation is not the population standard deviation, because it tells me that of these 50 cases, of this sample, t is equal, I get a standard deviation, that's a s for my standard deviation. So I'm going to use t. I'm going to write t equals x bar minus mu divided by s over the square root of n. Statistic minus parameter divided by standard deviation of statistic. And then I'm going to fill in numbers. X bar is 5.9 minus 6.7 the mu all over 3.1 divided by the square root of 50. And at this point, I'm going to go to my handy-dandy calculator. And whether or not we've done it in class or not, I'm going to go to stat and then over to tests. And on stat tests, one of the options that we get is the t-test. And that's what I'm doing. I'm doing t-test, and I have stats given, not the data. I have the statistics. And it asks me for my mu 0. You should be following along with me in your calculator. Mu 0, 6.7, x bar, 5.9, s, 3.1, n is 50, and I'm testing for less than. And I calculate. And I find that my t is equal to negative 1.82, and my p-value is 0.037. And then you might be thinking, well, what do I do with that? I'm going to draw a normal curve. Approximately normal, that's my t, or let's say that's my x bar. So ignore this t over here. And I am centered at 6.7. I got 5.9. This area down here is this 0.037. And I was told to check it at a 5% level of significance. All right, that 5% level is if I were to shade 5%, am I totally within that 5%? The answer is yes. Another way to check this is I look to see, is my p-value less than alpha? Level of significance is referred to as the Greek letter alpha. If my p is less than alpha, then I reject the null. I reject the null, and then I state, and this would be the long conclusion statement. I reject the null, I accept the alternative, and I would say, there is sufficient evidence to conclude at the 5% level of significance that the average time for medical attention has indeed decreased from 6.7 minutes. It is better than it was the previous year. Right, you can feel free to go back and rewind and listen to that again, but you need to say all of those things. So I make my conclusion statement, I reject the null and I accept the alternative. All right, so the null, or excuse me, this is true. And then I make a statement saying at a 5% level of significance, there is sufficient evidence to conclude, that the average time has decreased from 6.7 minutes. It is better than it was the previous year. All right. So then the second thing is, so if that's part A, maybe even part A and B of a problem, part C would say, describe a type 1 error in context. A type 1 error is where we reject the null and we shouldn't have. type 1 error is reject, because that's what we just did, reject the null, but I'm wrong. In this case, there was a 3.7, that's my p-value, % chance of doing a type 1 error. Alpha is equal to the probability of a type 1 error, type 1 is equal to alpha. All right, so that means I reject the null and I'm wrong. That is, I said that, so I prove, so a type 1 error is, I conclude that times have improved and I'm wrong. What's a consequence of that? Well, if I have just spent this whole year doing a lot of quality improvement and I've now made it to the point where I've shown that I've reduced the amount of time it takes to get to critical incident accidents, and I find out that I'm wrong, I might say, oh yeah, I've improved and we're just going to keep doing what I've always been doing, when in fact I haven't improved, which means that I am no better than I was last year, which means there are going to be still 22% of the people, remember that 78 originally, still 22% are not going to get the necessary help as quickly as they need to. All right, so I'm going to rest, and that's a bad thing for the patient. All right, then they'll say, what's a type 2 error? And, you know, what's wrong with a type 2 error? So a type 2 error is I don't reject and should have. So that is, I conclude that the times aren't improved when they really are. All right, times have not improved. So I conclude that times have not improved, but they really have. That is, I spent this year trying to do improvements, and I found out at the end of the year I really didn't make improvements. But the reality is I really did make improvements, just whatever I tested didn't show those improvements. So what happens in a case like that? Then I'm going to keep trying to do things to make things better, even though I know I already did things better. Is it going to cost me a little bit more money in the long run? Yes, because I already made improvements even though it didn't test that way. But no patients are going to be harmed in this process because I'm going to be continually improving. So which one is worse? Making a type 1 error is definitely worse. All right. And then lastly, when we talk about power is the ability to correctly reject the null. The ability to correctly reject the null. And power is defined as 1 minus the probability of a type 2 error. Okay? All right, and that's equal to, this is called beta. All right, probability of a type 1 error is equal to my level of significance alpha. Probability of type 2 error is beta. There is no relationship that we can just automatically describe that connects beta and alpha to each other. So do not think they are related. You can't. We are never going to spend pretty much any time. We'll just talk about it, but we're not going to ever show how to calculate beta. However, you will be asked to find power if you know the type 2 error. It's 1 minus beta. All right. So the smaller that the probability of a type 2 error is, the higher the power. All right. How do you improve power? This you will have to know. One thing is you can, N is increased. If you have a larger sample size, you have larger power. You're going to be able to detect smaller nuanced differences if you sample more. The other thing that makes power higher is alpha. Whatever the largest alpha is that I can stomach. If I want a larger alpha, so in this case, remember type 1 error was my worst. I don't want a big alpha. I want a small alpha. So if I want to increase power, I need to increase my sample size. All right. So that's power, type 1 error, type 2 error, a little bit with the t-distribution, and doing a hypothesis test. All right. So as you reflect back on this, for type 1 and type 2 error, what I want you to fill in for the reflection response is your understanding of this significance of power. All right. Again, a power is the ability to correctly reject the null. What are some consequences of having low power? What are some consequences of having a high power? And try to think in context of the last question that we just covered. If you can tie in context, that's always better to be able to link it back to the original problem. All right, folks, that's a lot. I talked fast. We'll see you in class.